Our Measurements Lab project is to find the best efficiency of a wind turbine by comparing orientations. Our group consists of me, Stacy Towers, Sergio Rodriguez, Johnny Frazier, and Dylan Lee. The purpose of our project is to determine the best orientation of a wind turbine to provide the highest efficiency, which is proportional to the voltage output. We will be changing the orientation based on the number of blades, blade type, and amount of pitch. Our number of blades will be comparing sets of 2, 3, 4, and 6 blades. We will test 5 different types of blades. For the pitch, we will compare 30 degrees and 60 degrees. Our apparatus consists of 3 main parts. The wind tunnel blows a constant stream of air into the wind turbine. The wind turbine is connected to the multimeter, which will read the voltage output.
For the input, the wind cannon is controlled by a dial. So we measured the velocity of the wind output at every revolution of the dial. As you can see here in the chart, at one revolution it produces a wind velocity of 0.5 meters per second, and our max is 8 revolution turns of the dial, which will produce a velocity of 8.5 meters per second. The wind turbine kit comes with 5 different blades for assembly. There are 3 long blades with different curvature types, codenamed type 28, 44, and 63, which have a set curvature, and there are 2 sheet blades which will be bent into shape by the wind turbine assembly. They are called the short sheet blade and the long sheet blade. When the wind turbine has been fully assembled, it is electronically hooked up to a multimeter to measure the voltage output of the wind turbine. After the wind turbine has been assembled and connected to the multimeter, a wind cannon is placed in front of the wind turbine, and it shoots out a set speed of wind velocity, which the multimeter will read.
For the setup of blade type 44 at a pitch of 60 degrees, an increase of the number of blades led to an increase of the voltage at each wind velocity. This means there was a higher efficiency for a larger number of blades. Comparing each blade type, you can see that the highest voltage output was from the sheet blades. The short sheet blade outperformed the long sheet blade. Also, from the profile blade types, type 28 performed the best. At low wind velocity, the long sheet blade and type 44 profile blade performed the best. Comparing the blade pitch, at low wind velocity, a pitch of 60 degrees performed better than the pitch of 30 degrees. However, at higher velocities, the pitch of 30 degrees outperformed the pitch of 60 degrees, meaning that there's applications for each pitch angle.